Continuing with quadratic modeling, the next problem that we're going to look at is how to get a quadratic model given our information in data form as a table of values. When we do this, we're going to use a technique very similar to what you did for linear modeling. We'll take the information in our table and we'll use our calculator to get the best fitting parabola in a process called quadratic regression. And we'll take a look at that in calculator in the context of our first example. So the average fuel economy, M, in miles per gallon, for a Toyota Camry traveling at speed v miles per hour is shown in our table. So here are our speeds from 30 to 70 miles an hour, and here's the fuel economy from 18 miles to the gallon to 25 miles to the gallon. So it's based on a scatter plot of the data. Why do you think a quadratic model is the best choice for this data? And could we tell without even looking at a scatter plot? So maybe we should actually talk about that second question before we look at the scatter plot. Is there anything you see about this data that makes you think, yeah, I shouldn't use linear regression, I should use quadratic regression instead? What I would point out is if you look at the y values, all through here, those y values are all increasing, right? They're getting bigger and bigger. But then look what happens here. They start getting smaller again. If you were using a linear model, lines always go up or always go down. They can't do both. The fact that we're first increasing and then decreasing indicates more of that parabola shape. So as far as the second question, I might say that the y values, or in this case the m values, increase and then decrease. We're going to need to put the data in anyway, so let's do that and actually look at the scatter plot. In your stat menu, you want to edit the very first option. And I'm going to clear out the old data. And let's just go ahead and plug these values in. And then the economy in the second column. All right, so I've got all my data in. And if I want to see this graphed on my coordinate axes, in my y equals, first of all, I'm going to clear out my old equation. I don't want that anymore. And then I'm going to turn the plot 1 on. In my window, looks like the maximum speed, which is in my x column, is 70. So if I go from 0 to 80, maybe I always like to give myself a little extra space. And the largest fuel economy value is 30. So let's see, maybe I'll go from 0 to 40. And I'll count by tens, that's fine. And then I'll just hit graph. And there's my scatter plot of these points. Now you'll notice that it doesn't make a perfect parabola, but it's certainly a lot closer to a parabola than it is to a straight line. So that also tells me that quadratic regression is the better choice. So my scatter plot has sort of a similar to a parabola shape. Definitely not a line. So it looks like a parabola, increases and then decreases. Tells me, yes, quadratic for the parabola is what I want. So if I go back into my stat menu now, and this time I want to calculate. Oops, I'll choose option number 5, which is quadratic regression. And just double check. We did use L1 for the x values. We did use L2 for the y values. I'm going to leave these two both blank, and then just go ahead and calculate. And there we go. In our standard form, ax squared plus bx plus c, it's giving me the a, b, and c values. We'll talk about that r squared in just a minute, but let me just write down what I have first. So let's see. According to the calculator, I would have y equals negative 0.017 if we use 3 decimal places, x squared plus 1.905x minus 24.864. Okay. Now, I really should use the variables that I was given, so let's rewrite this one more time. Y is actually m, the fuel economy, and x is actually v, the speed. And so there's my model for this data. Before we get done with the regression, I just wanted to mention this r squared. This is the square of what's called the correlation coefficient. The closer that is to 1, the better the model fits the data. So 0.93 is not bad. If your correlation coefficient or your r squared is not showing up, I can show you how to get it if you want it. If you go down to your calculator, go down to your catalog above the 0. So second catalog. I'm looking for diagnostics, so I'm going to skip to the D's just by hitting the, what would it be, this key right here that's got a D above it. And then scroll down to find diagnostics on. I want that, so I'm going to hit enter. And then I have to enter once more. It'll tell me done. And if you weren't seeing it before, if you go back to your stat again, calculate your quadratic regression one more time, you should get the r squared this time. All right. Let's do a couple of things. I've got a bunch of questions to answer here. Before I do, I'm going to go ahead and in my y equals, I'd like to put this equation in here because I'd like to see how well this fits. The regression correlation coefficient, the r squared, indicated that it should be a pretty good fit, although not perfect. It wasn't a perfect one. So let's see how well we did. If I type in my equation, and I will have to use the x form, and graph it. Although it's certainly not perfect, you can see that that parabola comes pretty close to most of the points here. So it seems like a reasonably good model. Now that I've done that, I can also use my calculator to help me answer a couple of other questions. So I had an ulterior motive here. I've been asked to find m of 25 and explain what it means. Now, of course, one option would be to go ahead and plug the 25 in here for V. And I'll let you grab your calculator and do that. But as long as I've already got the graph, another way to get that number is just to go into second calc and ask for the value when x, or in other words v, is 25. And it gave me about 12.1. Same answer as you'd get if you just typed this in by hand, but a shortcut. All right, so what does that mean? Well, the 25 went in for v. So the 12.1 is the m. That means at a speed of 25 miles per hour, the Camry gets about 12 miles to the gallon. Now, you can argue that that's not realistic. In fact, it probably isn't. I think Camrys do a little better than that. But at least according to our model, that's the case. And that's actually really important. We're going to talk about that according to the model in just a little bit. All right. D, find V so that M of V is less than or equal to 22. And explain what that means. So let's see. M of V is this equation right here. And I want that to be less than or equal to 22. Once again, I'll use my calculator to help me out here. In my y equals, I'm going to turn the plot off. I don't really need to see the points anymore. I really only need to see the model. So that's the left-hand side. And then I'll put the 22 in for the right-hand side. And let's graph those. Looks like I probably have everything I need. Might not hurt to have a little bit more over here, maybe just to make it look a little prettier. Let's increase the x values to 100. There we go. So, I would like to know, when is this parabola, the quadratic, less than or equal to 22? Let me sketch what I see. If I want to know when the m is less than or equal to 22, I'm looking for the parts down here. So let's use the calculator to get the x values at the intersection point. Intersect. Get that smaller one first. It's about 36.5. And we'll do intersect again. And this time we'll move over and get the larger one. About 75.6. So what is this telling us? Well, this is the fuel economy. It's saying we get less than or equal to 22 miles per gallon if we drive under 36.5 miles an hour or over 75.6 miles per hour. So the Camry's fuel economy is less than or equal to 22 miles per gallon at speeds below 36.5 miles per hour and also above 75.6 miles per hour. All right, and then the last question about this one, at what speed does the Camry get the best fuel economy? And we've seen this so many times now, I'm sure you're all way ahead of me. If that's my fuel economy parabola, the best fuel economy, the maximum miles per gallon would be the vertex. So let's see, I'm going to get rid of the 22. I don't need that anymore. And then I'll calculate the maximum. And it looks like the x value here is about 56 if I round to the nearest whole number. Y value is about 28.5. So the best fuel economy, according to our model, would be at 56 miles per hour, where we're getting 28.5 miles per gallon. All right, there's something kind of important here that I do want to point out, and that is this idea of according to the model. You'll see that a lot when we're doing modeling problems. And when you look back at the chart, you'll kind of see why. In fact, according to our actual data, we can do better than 28.5 miles per gallon. In fact, we can see it a couple times right in here, right? So in reality, the best fuel economy is somewhere between 55 and 60, and we're getting at least 30 miles to the gallon at those speeds. Why did my answer come out different? Well, let's go back to our calculator again. And I'm going to turn my plot back on and graph again. Our model is the curve, the parabola. But notice there are some data points that we miss a little bit. And in fact, right here, I'm missing those maximum data points. So according to the model, the maximums are going to occur at the top of the parabola, the vertex. But according to the data, it will actually be at the data point that's a little bit above that. So when you're asked this question, just keep in mind, when you're asked according to the model, you may get an answer that's a little bit different than what you actually saw in your data table. All right, we'll wrap up this section with the next video.